Hey, welcome back. This is episode 2 of the Salesforce Clouds Decoded. Today, Data Cloud Foundations, DSO, DLO, and DMO architecture explained. Mastering the canonical information model, ingestion streams, and mapping semantics. Let's get into it. Here's what we're covering today. Data ingestion architecture and stream types, then, data source objects, DSO, versus data lake objects, DLO, then, the cloud information model, CIM, standard, then, primary key and fully qualified key, FQK, semantics, then, mapping DLOs to standard and custom data model objects, DMO. Stay for the last one, it's the piece most tutorials miss. Let me explain this simply. Welcome back to Salesforce Clouds Decoded. In episode 2, we are breaking down the absolute foundation of Salesforce Data Cloud, how data transitions from raw external payloads into harmonized enterprise profiles.
I always get confused between data source objects, data lake objects, and data model objects. How does the mapping pipeline actually preserve schema integrity?
Salesforce Data Cloud decouples raw ingestion from analytical modeling using a structured three-tier architecture. When external data arrives via batch or streaming pipelines, it first enters as a data source object representing raw payload structures. This raw payload is immediately materialized into an immutable data lake object inside the managed data lakehouse. Finally, architects map these DLO attributes into standardized data model objects based on the cloud information model. This clear separation ensures source system schema changes never break downstream harmonization or segmentation workflows. Every data stream in Data Cloud requires you to categorize incoming data into one of three core categories: profile, engagement, or other. Profile data represents nouns like individuals, accounts, and contact points where record updates overwrite previous state snapshots. Engagement data captures time series behavioral events such as email opens, web clicks, and purchase transactions that are purely append-only. Selecting the correct category is irreversible and dictates how storage partitioning, indexing, and identity resolution engines process the ingested records. Once a data stream is activated, Data Cloud creates a physical data lake object backed by columnar Parquet files in Apache Iceberg format. DLOs preserve raw source attributes without destructive schema truncation, enabling full auditability and replayability. Each DLO automatically receives system metadata fields, including ingestion timestamps, batch IDs, and source connector identifiers. Because DLOs are read-optimized for distributed compute engines, they can ingest billions of streaming rows without imposing transactional row-lock constraints. The cloud information model provides an open-source, standardized enterprise schema across sales, service, marketing, and commerce domains. Instead of writing custom point-to-point transformations for every source system, architects normalize diverse source fields into standard subject areas like party, engagement, and product. For example, a Shopify customer ID and an SAP business partner both map into the standard individual and contact point DMOs. This semantic standardization allows unified calculated insights and segmentations to run consistently regardless of where the data originated. The heart of Data Cloud's canonical model is the party subject area, designed to handle complex real-world contact hierarchies. An individual DMO represents the human identity, but it deliberately does not hold direct communication channels like phone numbers or emails. Instead, child objects like contact point email, contact point phone, and contact point address maintain separate one-to-many relationships to the individual. This normalized structure is critical because a single customer often has multiple personal and work email addresses across different enterprise touchpoints. In multi-source environments, primary key collisions are inevitable when two disconnected databases generate identical record IDs. Data Cloud solves this critical problem through fully qualified keys by prefixing the raw primary key with the source system identifier. For instance, Customer ID 101 from Salesforce CRM becomes CRM_101, while customer 101 from POS becomes POS_101 within the DLO layer. This programmatic key qualification guarantees global uniqueness across multi-tenant lakehouse partitions and prevents accidental row overwrites during ingestion. Mapping transforms raw DLO attributes into canonical DMO fields through visual canvas configuration or declarative transformation formulas. Architects define field-level mappings, specify relationship cardinalities, and apply custom formula functions to clean raw data before harmonization. Crucially, multiple DLOs from completely different sources can map to the exact same standard DMO, such as populating individual from Service Cloud and Marketing Cloud simultaneously. If standard CIM objects cannot capture your domain attributes, Data Cloud allows creating custom DMOs with full relationship parity. Designing a scalable data cloud foundation requires strict adherence to modeling best practices from day one. Always validate that your primary keys and foreign keys match exact data types and qualification formats before saving mappings. Never map raw transactional line items into profile categories. Always assign time series purchases to engagement objects to preserve event ordering. Lastly, thoroughly plan your party identification mappings because downstream identity resolution algorithms rely entirely on accurate contact point and identifier keys to merge duplicate profiles. Alright, let's wrap up. Here are the key things to remember. DSO is the transient schema, DLO is the immutable storage layer, and DMO is the unified semantic model. Stream categories, profile, engagement, other, permanently determine how data is partitioned and processed. The CIM Party model decouples individuals from contact points to support real-world multi-channel customers. Fully qualified keys, FQK, eliminate source key collisions across distributed enterprise systems. If this helped, hit like, it really helps the channel. Next up, Episode 3, Data Cloud Identity Resolution, Rule Sets, Reconciliation Rules, and Unified Profiles. See you tomorrow.